Hey guys, welcome to day 6 of 100 Days of Code. And well done for making it this far. So today we're going to talk about code blocks and indentation, as well as functions, and also a different flavor from the for loops that we saw yesterday. Today we're going to talk about while loops as well. And to learn all of these things, we're going to use the help of something that's very similar to Carol the robot. And this is something I used when I first learned how to code. And it's one of my favorite tools for learning programming, especially as we get into more difficult concepts like functions and while loops, etc. And by the end of the day, we're going to be writing the code that's required to instruct our little robot to be able to complete any randomly generated maze. So that's the goal. And if you head over to the next lesson, let's get started and let's start learning about some of these things. The first concept I want to introduce you to is something called functions. And just as we perform many different functions, it could be mother, father, son, daughter, we can also get our code to perform different pieces of functionality. Now, if we think back, we've actually already come across functions, and I've been referring to them every time we've needed to use one. If you take a look at this link in the course resources, which takes you to the Python documentation, then you can see that Python has a whole bunch of built-in functions that we've been using. For example, the len function, which gives us the number of items in a collection, or the int function, which turns something into an integer, or the print function, the range function, and other ones that we haven't seen yet. If you head over to the day 6 starting replit and go ahead and fork a copy of it, then we can start typing one of the functions that we've been using a lot, which is the print function. And the reason why we know it's a function is because it's the name of a function followed by a set of parentheses. Now we know that if we put something inside these parentheses, say for example hello, then when I run the code, whatever is inside those parentheses will get outputted over here in the console. Now all the functions work pretty much the same. So if I wanted to use the len function to see, well, how many characters are there in this word hello, I again put my hello inside the parentheses, and because of the parentheses, we know that this is a function, and then I can save the outcome of this length function to a variable. Say, let's call it number of characters, numchar, and then I can go ahead and print it in order to view it inside the console. So let's print the num underscore char, and now you can see that this len function gets to work, calculates the number of characters, it's 5, and then it gets printed. So all of this functionality has been achieved by these built-in functions from Python, like print and len. Now, what if we wanted to make our own functions? How would we do that? Well, if we want to make our own function, we first start out with a keyword, which is called def. And this is because we're creating or defining our function. Now, after the def keyword, we can give our function a name. And I'm just going to call it my function. Now, the thing that differentiates a function from a variable, however, is the parentheses. So after the name comes the parentheses, and now the final thing, the finishing touch to our function definition, is a colon, because that says everything that comes after that line and is indented belongs with the function. Let's make a really simple function that just has 2 lines of code. Maybe it prints hello, and then it prints bye. So now I've created my function. I've placed the lines of code that are associated with this function all indented after the definition. But notice how if I go ahead and run my code, actually nothing will happen. And the reason is because we haven't yet executed the function. Now we can define lots and lots of functions ahead of time, and it's only when we actually need it do we go ahead and trigger it? And to trigger it, or in programming lingo, we would say to call the function, all we have to do is type the name of the function, which is my function, and then to add the parentheses and any necessary inputs. In our case, our function doesn't require any inputs, so we can leave the parentheses blank again. And now if I go ahead and run my code once more, then you'll see that by the time the computer reaches line 5, it's going to search for this thing called my function. It sees that it was defined right here on line 1, and it goes through all of the content and executes them in turn, line by line. And that's why we get hello and bye being printed here. So just to recap, this is how we create a function in Python. There's 2 steps to it. The first step is to actually define the function, to specify what it should do. And we do that by first using the def keyword, and then we give our function a name. So for example, in this case, I called it my function. And then comes a set of parentheses and a colon. And then after that, we get to put the lines of code which will be included in this function. And remember that these lines of code which goes into the function, which will be carried out when this function is triggered, must be indented like this. So once you've defined the function, you've created the recipe, the next step is to actually use it, which in programming lingo, we would say calling the function. And we call the function just by specifying the name and a set of parentheses. And once the computer sees this line of code, it'll know to go and carry out all the instructions inside where we defined our function. And to learn about functions, I'm going to introduce you to something that's very similar to Carol the robot. The robot is going to be something that is just going to perform the tasks that we want it to, and no more and no less. So for example, if we wanted a robot to go to the store and pick up some milk for us, we can't simply just tell it, oh yeah, just go and buy some milk, because it won't know how to do that unless we give it specific instructions, such as leave the house, walk 2 blocks to the right, walk 4 blocks back, and then 2 blocks to the right. When you go to the store, give them some money, and then take the milk and come back. We have to program each and every step. But say if this functionality of getting the robot to go and pick up some milk for us is needed every single day, then we have to write out all of those instructions day after day, day after day. And at some point, our fingers are going to hurt, right? We're typing so much code that's repeated because we don't have a way of bundling all those instructions together. And that's where functions come in. Functions will give us a way of referring to all those instructions at the same time. That way, we can give our robot a single instruction and it will carry out all of those little steps for us and get us some milk. Now, to try this out yourself, I want you to head over to the course resources and click on the link that takes you to Reborg's World. Now, Reborg's World is very similar to Carol the robot that I showed you earlier on, but it allows us to write Python code. And it's very easy to get started. Now, we've got this area here, which we're going to use to write our Python code. And then once we're done, we can click on play to run the Python code and see the instructions carried out by our robot. If you click on Reborg's keyboard, you can see all of the functions that we can use to command our robot, like move or turn left or build a wall, etc. Let's see if we go ahead and run this line of code here, move, what happens. When I click play, you can see that our robot moves forward in the direction that it's facing by 1 step. So if we wanted it to move, say for example, 3 steps, all we have to do is to call the move function 3 times. Now let's reset by clicking the return button to return our robot back to the starting position. Now let's click play again in order for our robot to carry out the new instructions. Notice how all the instructions were carried out very quickly. To execute each instruction 1 step at a time, line by line, we can use this step through button. This button allows us to see how each instruction is executed. And after each instruction, it pauses and highlights the next instruction. This is very helpful for debugging. So notice how we're highlighting line 2. So if I click on step again, it's going to carry out that function, and then it's going to carry out line 3. And finally, it reaches the end, and that's the end of our code. Now, in addition, we can use some of the other commands in the keyboard. For example, turn left. If I decide to say move 3 times and then turn left, and then maybe move 3 times again, can you predict which square the robot is going to end up in? Are you ready? Let's go ahead and run the code. There we go. We end up on the square 4, 4. It moves 3 forwards, turns left, and then moves 3 steps again, because that's what we told it to do with our Python code. So now here's a question. If you take a look inside the set of commands, you'll notice that there is move and there is turn left, but there is no turn right and there is no turn around. So how could we use a function to create those commands? Because of course we could just simply write turn left and then turn left again. And this would effectively turn the robot around, right? But if we want to do that many times, say for example, if we wanted to go to 3, turn around, go back to 1, turn around, go back to 3, then we would have to write code that looks a bit like this. We would have to say move 2 times to get to square 3, turn left, and then move 2 times again to get to 1, and then turn left again in order to turn around. This is all the code we would have to write to achieve this kind of effect. But instead of all of this, we could just define a new function. So we use the def keyword to say that this code is defining a new function called turn around. And this function is simply going to be turn left twice. And remember, all the code that's going to go inside the function has to be indented. And now, instead of writing turn left, we can simplify our code by telling it to call the function turn around. And we can do that here, and we can do that here. So now, when we run the code, you'll see that it does exactly the same thing as before, but this time we've cut down 2 lines of code. So instead of 8 lines of code for our instructions, we only now need 6 lines. And you can see that the more that you need to use this function, the more typing it will save you. But more important than reducing the number of lines of code is that our code has also become a lot more readable. So the turnaround function is much more clear than having turn left twice. Now let's see what happens when we use the step through button. Look closely at how each line in our code is executed. So now we're going to carry out the move by 1, and now it's going to call turn around, that function. And it jumps over to find this function and carries out the code inside, in turn, from the top to the bottom. So turn left, and now once that function's done, it goes back to where it was before and continues running. Move, and then turn around again. So here's your challenge. Try and create a separate function that turns our robot to the right. Pause the video, head over to the course resources, and click on the link that takes you to Reborg's world, and then go ahead and create your own function called turn right. All right, so this should be pretty simple because all we have to do is to define a new function called turn right. And this function is going to simply be turn left 3 times. Because turning left 3 times is going to effectively turn our robot right. So even though we only have this one way of turning our robot, we can define our own functions to give it many other commands that it could use. So now, using this turn right function, see if you can write some code that makes our robot draw a little square going from here to here, then to here, and back to the beginning. Once you're done and you hit play, this is what should happen. So pause the video now and see if you can complete that challenge. All right, so let's go from the beginning. We start out facing right at the position 1, 1. In order to draw the square starting from this way, we have to first turn left. And then we have to move one step, and that should take us to here. And now we have to turn right, move one more step, turn right again, move one more step, and finally turn right for the last time and move one more step. So using our awesome function means that we don't have to write out turn left 3 times each time we need to turn right. So our code can just be 8 lines long instead of 14 lines long. And we're using our function to cut down on a lot of typing. But not only are there fewer lines of code, look at how much more readable our code has become thanks to our turn right function. It's now so much easier to read, turn right, and understand what it needs to do rather than seeing turn left 3 times in the code. So now it's easier to read and it's easier to follow the logic in our code. In the next lesson, I've got a challenge for you. Head over there and apply what you've learned about functions to try and solve it. I'll see you there. All right, so now that you've learned about functions, I have a coding challenge for you. If you head over to this link, which is in the course resources, and head over to this challenge, which is called Hurdle 1. The idea is that we've got a robot here, which needs to do a number of hurdles to jump over each of these barriers to get to the final goal here. Now, you need to use your knowledge of functions as well as some of the things you've learned before, such as the for loop or the range function, to be able to achieve this. Now remember that you can tell the robot to move by typing move parentheses, and when that's run, it will move by 1 space. And you can also use, say, turn left to get the robot to turn left. And in this case, when I run the code, it's going to move 1 space and face to the left. In order to complete this entire challenge, you can see there's a number of steps that the robot has to go through before it can get to this final goal. And if you were to write out each of these steps, like I have done here, one after the other, it would take many, many tens of lines of code. And that's not what we're about. We're programmers, so we're born to be lazy. Try and see if you can minimize the number of lines of code while still keeping your code readable and understandable by somebody else, and be able to get your robot to complete these instructions and take the robot to the final goalpost. And once you've completed the challenge successfully, you should get a green pop-up that says you're at the correct X and Y position. So pause the video now, head over to this link, and give this challenge a go. All right, so how did you get on with this challenge? How many lines of code did it take you to tell this robot to get to the goal? All right, let's have a think about how we might tackle this. We know that out of the things that we can tell the robot to do, the most useful things are to move and to turn left. But because the robot doesn't have a built-in turn right function, then we have to define that ourselves. And the reason why we need to do that is because you can see it at several points during the hurdle, we'll have to turn right. For example, when the robot is here at 2, 2, it will have to turn right and then move, and then turn right again and then move. So let's create a new function called turn right. So we start out with the def keyword and then give our function a name, which is going to be turn right. And then we add the parentheses with nothing inside because we're not passing any inputs to this function. We're just going to use this function as a way of defining turn left 3 times. So when you turn left 3 times, of course, you turn right. And now we have the ability to turn right. So notice how this is the code block for our turn right function, and it ends at the last line which is indented, which is line 4. So every subsequent line which starts at the very beginning of the code file next to the left margin is outside this code block, and it will act independently. So in fact, the first line of code that actually runs in our file is going to be this line 6. And you can see that when I press run, you can see that's the first thing that gets highlighted. And if I go through this stepwise, you can see the first line is going to be line 6, and it tells the computer to go and find this function called turn right. So if I skip to the next step, it's found that, and it's going to start going through lines 2, 3, and 4, turning our robot 3 times until it has turned right. Now that we have the ability to turn right, let's have a think about how we might be able to get our robot to make one jump. Let's see. The first thing we'd probably want our robot to do is to move forwards by 1 step, which should take it here. And then the next thing we want it to do is to turn left so that it faces the top. And once it's in this position, then we want to get it to move forwards 1 step. And then we'll probably want it to turn right. Now, notice how I'm actually testing my code at pretty much every other line that I write. And this means that you don't end up in a situation where you get to the end and you've written lots and lots of lines of code and it doesn't work. In which case you have to comb through all of the code you've written and find out where the problem is. So in this case, we've only got 4 lines and we've been testing it stepwise. So we can see that we're on track and our robot is now turned to the right, ready to move 1 more step. And then once it gets to here, we have to turn right again and move 1 more step. And now it should end up here, but let's just check it out. So our robot turns left, turns right again, and it ends up here facing the bottom. So the final thing we need to do is to get it to turn left once more, so that it will face the forward direction. So once you've confirmed that your code is working, then you should really think about what is the next step, because we've managed to make 1 hurdle. And notice how when we're at this position, 3, 1, this particular square, it's almost the same as if we were at 1, 1, because we have to move 1 step again, turn left, move, turn right, move, turn right, move, turn left. So it's basically repeating all of these instructions. Rather than executing these instructions 6 times, because there are 6 hurdles. So if I go back and I start, then you'll see that this code actually will complete the challenge. It says, I'm done, and we're at the correct position. But notice how many lines of code we've got. We've got something like 58 lines of code. I know I've left some spaces in there so that you can see which parts are repeating, but still, that's a massive amount of code for something very simple. Now we know that we can use functions to package a set of instructions together under 1 name, just like what we've done here with the turn right. We've packaged the 3 lines of code, turn left, turn left, turn left, into a single function called turn right, so that when we need that functionality, all we need to do is just to call the function and add the parentheses at the end. So we can do exactly the same thing with this set of instructions, which basically gets our robot to perform a single jump. So let's create a def and let's call this function jump. And then let's add the parentheses and the colon. And very importantly, all of these lines of code must be indented. So to indent a whole block of code together, you hold down the command key and click the left square bracket or the right square bracket. On Windows, it's holding down the control key and again the left square bracket or the right square bracket. So now this basically says that all of these instructions live inside this block of code called jump. And when we call jump, then it will carry out all of these lines of code. So now what we could do to complete the challenge is to simply call this function jump 6 times. And so now we could again solve this entire problem using just 21 lines of code. And we managed to complete this challenge using 2 functions that have repeated instructions and then calling the jump function 6 times. But because we've learned about loops and the range function, we know that we can actually cut this down even shorter. So instead of calling jump 6 times, we could actually write a for loop that loops through and calls this jump function 6 times. We could say something like for step in, and remember that these 2 keywords come from the for in loop and they always have to stay the same. And then after the in keyword, we define the rules for how many times we want our loop to repeat. In my case, I'm going to use a range function, and I'm going to say from 0 to 6, but not including 6. So in this case, it will be 0, 1, 2, 3, 4, 5. So that's actually going to happen 6 times. And now I'm going to add the colon, and finally inside this for loop, I'm going to call jump just once. Now watch what happens. First, it starts off at the for loop, it calls jump, and it goes through this once, and then it comes back, loops again, calls it the next time, and then again, the 3rd time in the loop, 4th time in the loop, 5th time in the loop, and 6th time in the loop. How far did you manage to get? Did you get stuck on this section where we needed to create the for loop? Well, in that case, I recommend going back to the lesson where we covered for loops and reviewing the for loop and the range function in detail before you come back and try to solve this challenge again. It's really, really important at this stage that you've understood and you've mastered some of these ideas, because we're going to be using them more and more in the future. Really make sure that you've understood things before you keep going.